All right, so example 9 is using logarithms in the logistic growth model. So they give us this equation here, and it says, suppose the carrying capacity M of the human population on Earth is 35 billion. In 1987, the world population was about 5 billion. We're going to use the logistic growth model here to calculate the average rate K of growth of the population, given that the population was about 6 billion in 2003. All right, so what do we know here? Well, it started out, it said in 1987 the world population was about 5 billion. So that tells me, well, we'll just go through the statement again. So suppose the carrying capacity M of the human population on Earth is 35 billion. So we know that M is going to equal 35 billion. Okay, in 1987, the world population was about 5 billion. So that's going to be our starting. So 1987 is where T is going to equal 0. And so that means that the population, then at times 0, P of 0, is going to equal 5 billion. All right, so we're going to use this stuff here first so that we can find an A, because we don't have an A, and then once we find A, we can plug it in to find our K, our growth rate. All right, so using this equation here, we know that P of T, so 5, is equal to 35 divided by 1 plus A E to the negative K, but we know T is 0. And this is how we're able to solve for A, even though we have other variables. When T is 0, that's going to make that exponent there be 0. All right, so on that, let's simplify. So we're going to be able to multiply this. So we still have 5 equals 35 over 1 plus A E to the 0. And remember, 0 exponent, the answer is 1. So I have 5 equals 35 over 1 plus A times 1, which just means 5 is equal to 35 over 1 plus A. Now again, I'm just going to put this over 1, and we're going to cross multiply. So when I do that, I get 5 times 1 plus A will equal to 1 times 35. So 5 plus 5A equals 35, and let's just solve for A. So I'm going to subtract the 5. So 5A equals 30, divided by 5, and we find that A is equal to 6. Now, we want to know the average growth rate, K, of the population, given that the population was 6 million in 2003. So now we're going to kind of switch over here. Let me see, I'm going to draw a little squiggle there. Now we know that M is still going to be 35. What was that, billion? Our T is going to be, let's see, we're looking for in the year 2003. And so from 2003, and from 1987 to 2003, that is 16 years. And we know P of T is going to be that 6 billion, and we know that A is also 6. So let's plug in what we know then. Ooh, so I'm almost out of room here, so I'm going to kind of squeeze it in a little. So I'm going to change colors to make it a little easier. So P of T equals M over 1 plus A E to the negative K, and T was 16. So again, we can put this over 1 and just cross multiply. I'm going to rewrite that where it looks a little more like cross multiplication, sort of. So we're going to multiply. So we got 6 times 1 plus 6 e to the negative 16k equals 1 times 35. And so let's see, we're going to distribute this. Let me see, I'm going to separate a little bit here. Distribute this 6 right here. So 6 plus 36 e to the negative 16k equals 35. And then we're just going to get the exponential part by itself like we did before. So subtract the 6. So 36e to the negative 16k equals 29. Divide by the 36. I'm going to run out of room. And so we got e to the negative 16k equals 29 over 36. All right, so I'm going to have to erase this that I have over here on the left to make room. All right, so I'm going to write my last step there. So I have e to the negative 16k equals 29 over 36. And now we're back to just solving. We got the exponential expression by itself, so we're going to log both sides. So the natural log of e to the negative 16k equals the natural log of 29 over 36. Then we're going to use the power rule, so we're going to take that negative 16k and move it in front of its log. So negative 16k times the natural log of e equals the natural log of 29 over 36. And do you remember what the natural log of e is equal to? Natural log of e is 1. So we just have negative 16k, because times 1 is just still negative 16k, equals the natural log of 29 over 36. Solve for k, so divide by the negative 16. And k should equal approximately 0.0135. Now remember, this is our growth rate. So this is what we want, but it's a rate, so we need to put it as a percent. So our growth rate is approximately 1.35%. And that's what it was looking for.